Hello, my name is Ilashri Khatka, and I am an MSCIT student studying in the British College under the Leeds Beckett University. So I'm here to present my poster presentations on the topic classifying waste material effectively with image recognition. And this is my poster presentation, as you can see. So let's get through the presentation. First is the overview. So rapid increase in industrialization and urbanization has led to the increase in the productions of waste materials. As we know, the population is growing rapidly day by day, and along with it, several challenges arises. Um, Along with it, the major challenges is the proper waste management. This is one of the major challenges, and the traditional method where people in which involve people which was inefficient, tedious, and which cause health hazard because the laborers used to touch it and then dump in the landfills, which would cause hazards because the waste could be toxic. So therefore, and the large amount of waste used to be haphazardly thrown in the landfill and burnt it. It used to be burnt, which caused, which emit a lot of gases, and which was even hazardous to the environment. So, in order to solve these challenges, we need to develop a significant solution that is a system which is modern, sustainable, automated, and efficient. So therefore, this paper deploys a deep learning techniques like convolution neural networks, CNN, ResNet, and VGG16 for image classification in order to segregate the waste into organic and recyclable categories. Now let's go through the aims. The primary aims of the research is to develop a system, a robust waste management system, to categorize waste effectively in order to promote recycling and support the sustainable environment by implementing a deep learning techniques to create an accurate and efficient system. Um, let's go through the objectives. Objectives are first is to develop an automated system so that it successfully categorize them into the organic and recyclable, where organics can be further composed. It can be dumped and can be used for as a manure, compost manure, whereas recyclables waste can be further reused again and recycled again, can be reused again. So the other objectives is to utilize the deep learning techniques like CNN, ResNet 50s, and VGG16 to precisely identify and compare the results, since we know that CNN are the pioneer for the image classification. And CNN based techniques like ResNet 50s and VGG16s are employed. And the other objective here is um, to develop a system so that we can upscale this system and use for the future, for the helpful of man for the help to the mankind, so that it can improve recycling rate, lessening the use of landfills, and uplifting the sustainable waste management. To make the resources sustainable so that it can be used for the present as well as for the future. So let's go to the rationals. So rationals are first is uh, the project has been done so that we can challenge the increasing volume of this to manage it successfully and to challenge the traditional method, which was tedious, time consuming. It was very error prone, and it also risked the life of the peoples who used to manage it. So in order to solve such challenges, the system is developed, and The other is, despite the emerging applications of advanced artificial intelligence technique, particularly convolution neural networks, in automated waste sorting, the research has worked to improve the precision rate and demonstrated the potential of AI in enhancing classification accuracy and efficiency. Now, CNN has the potential to revolutionize the waste management accurately and classifying them into properly successfully into categories like recyclable and organic in this research. Now let's go to the literature reviews. Lots of research, considerable amounts of research has been done, and there were a lot of papers and have gone through a lot of papers. So there was lots of techniques has been used, like in machine learnings and deep learning techniques are used. Lots of varieties of data set has been employed. Techniques like hybrid models has been used. Transfer learnings has been used, or any deep learning techniques, which is more efficient for the image recognition here. So it is more reliable techniques. That is CNN, ResNet 18, ResNet 50s has been employed. Challenges also has been faced, like for the diversity of data set, as in order to match the real world, sometimes it can be really challenging in the project. Now let's go through the methodology. First is the data visualization and exploration. So the data set for this project has been extracted from the Kaggle, which is an open platform source. So the data set was labeled data set, which was in organic, and which was divided into test and the trained data set, and test and train data sets, and it was further into recycle and the organic, recyclable and organic. It was divided in further recyclable and organic. Now comes the pre-processing and augmentation process. Now we know processing is a crucial process where raw data are cleaned before training. So pre-processing is done in order to improve data qualities and enhance model performance. And your pixels are resized into 224 into 224s, where followed by normalizations, where pixels divided by 255, so that it ranges from 0 and 1. Then followed by data augmentation process, which helped increase size and the diversity of data set. Certain augmentation like rotation, 20 degrees, horizontal shift by 20 degrees, and vertical shift by 20 degrees has been done. And then comes the model design, design like CNN, ResNet 50s and VG16 has been used. As we know, CNNs are the pioneer, is very exceptional, gives an exceptional result for the image recognition. So CNN and CNN-based model has been deployed. Now then we go to the when we go to the model compilation. Now this is also a very critical step where we configure model for training. So in this here model optimizer, choosing an optimizers like Atom optimizers is used. Measure your loss functions are measured, and your optimizations are done through the back propagations. Now then comes the model training process. Your model training process is also is a crucial process. Here we learn your model learns patterns from data to make accurate predictions. So hyperparameters like batch size, which is set to 32, 64, epoches, epoches are done, and loss functions or dropout rate is used. These are all used in order to prevent overfitting. So then comes the model testing. Model testing is a process which involves evaluating the trained models on unseen data. This is also done in order to measure the performance. So where these, as we know, the label data set we extracted, which was in 90 by 10 ratio. So 90 ratio, this is done for model training, and 10 for the model testing, where it categorize it perfectly, the models categorize it perfectly into organic or recyclables. Then comes the result evaluation. This is done by the metrics like F1 scores, where results are compared using F1 scores, accuracy, validation accuracy, recall, and precisions. Now, now let's discuss the resultant discussions. Now, the CNN model has achieved an exceptional result of validation accuracy of 90%, with precisions of 90%, recalls of 85%, and F1 scores of 88%, whereas VGG16 has achieved an accuracy of 87%, and ResNet 50 has achieved accuracy of 80%. And all the models were successfully able to segregate the organic and recyclable effectively as um, perfectly. So now let's go to the conclusion. Now, in conclusion, the implementations of the convolution neural networks, CNN and CNN-based models, ResNet 50, VGG16 has transformed the traditional labor-intensive waste management system. By harnessing the image recognition capabilities of CNN, waste is accurately sorted into organic and recyclable categories without any human involvement, reducing health risk and decreasing the landfill waste. Now let's go through the ethical consideration. Now the research has been done with taking full consideration of ethical consideration. Your the research ensures the integrity and ensures the integrity, since the data set has been extracted where from the publicly available platform Kaggle data set, maintaining confidentiality. No a data breach has been done. No consent was so required, as this was only images of the waste images. No human involvement no human involvement is done, and integrity has been completely maintained. Whereas we have taken past research papers into consideration of the waste management system using the CNN techniques. But ethical consideration has been taken into major concerns. It has been to topmost priority. So, by saying this, I would like to conclude my presentation. Thank you.